Hello all. Welcome to Data Science with Julia. So today we are going to talk about a term called data drift. Uh, okay, like I just heard this term data drift when I was speaking with somebody, and that guy said like it was asked in interview and all those stuff. So I just went and saw what it is and all those things. Okay, yeah. Another disclaimer I just want to add, like this course is not about like what to say, me guaranteeing you that you will get through interviews or something like that, or what these colleges and all promise. Like you will have a better future and all those stuff. This course is all about like me understanding data science and then sharing my blogs and videos with you. Okay, so it is as simple as that. Okay, so that's the thing. If you understand and if you're able to do something good with it, okay, well and good. If not, yeah, like that's the thing. It's your fate to have come across these videos and all those things. So, but yeah, I just want to discuss this term data drift because it's been asked in interviews and all. But don't think that okay, you have known from here. It doesn't mean that it's a concrete thing or something like that. So, that's a disclaimer I just want to add to all the videos in this playlist, Data Science with Julia. Okay, so that's the thing. To talk about data drift is like, let's say okay, yeah, average rainfall or something like that, right? In Chennai, the average rainfall is going to be one thing, and in Cherrapunji, that is another place in India where the average rainfall is the highest in the world. It used to be another thing. So a drought in Cherrapunji is really different from a drought in Chennai. A drought in Chennai means absolutely no water, right? So there is very, very little water. A drought in Sahara might be a very different thing. Okay, so Sahara or something like the Arabian deserts or something like that, that will be a very different thing. So people would have evolved and all those stuff. So look, this all depends on the kind of data. Like in Chennai, like if the rainfall is like only like few tens of millimeters per year, possibly that's very bad. In Cherrapunji, if the rainfall is just I don't know, like exactly like 1 feet a year or something like that, it might be very bad. Who knows? Like so that's how it is. So like when things change, or that is in this case location change or something changes, the amount of volume of the measure also changes, and depending on that you should what to say, uh, retrain your algorithms. AI algorithm might say like okay, just 5 millimeters of rain per year for Chennai is drought, but that can't be said for some Arabian desert or some African desert or something like that. Okay, so that's how it is. So yeah, we'll just use plots. Okay, this I'm not going to do with notebooks because this is a very straightforward thing. But yeah, of course, you can find this notebook when you come to my blog and come to the last. You'll just get the notebook link. Okay, so that's the right. So you just have this days like Monday to Friday, right? So and okay, yeah, why can't I do a notebook? Okay, yeah, let me just do it so that like if there is mistake or something, I will find out. Like, okay, next thing I need to explore is a thing called Pluto. Like, it is kind of Jupiter. I just think a Jupiter notebook. Wait, let me go and look into Pluto. Pluto JL. I fully didn't understand what it is, but I just want to tell you people like if you can, yeah, you can just what to say. Yeah, they say it's some kind of interactive notebook or something like that. So, uh, uh, okay, so I'm not sure exactly what it is, but yeah, I need to try it, and I'll post it in this blog and my video log in data making, right? So that's the thing, right? So this seems to be much more interactive notebook or something like that, but yeah, I need to see, right? So let me look into it, right? But yeah, please do know that okay, there's a thing called Pluto that exists, and you could try it out. And even though I haven't tried it out, okay, so yeah, so you just have a thing called days that is like Monday to Friday, right? So uh, Okay, and you just have a variable called 2020 travel time. Okay, and it gives an error. That's because variables in Julia should not start with a number. Okay, as simple as that. Why it, almost in every programming language, whatever starts with a number, right? So in this case, it's two, right? There is a thing called, look, computers are not as intelligent as humans. Like maybe they might be the best chess player or something like that. But when it comes to very general intelligence, no, right? So we know that okay, this could be a variable, but for a computer, like if something starts with a number, it means a number. Okay? So that's the thing. So it won't take in as variables. Okay, so that's the thing. So rather than putting like this, we'll just put like travel time 2020. Yeah, I'm just doing it so that like yeah, like some people will know about plotting from this video or something like that. So we have travel time 60 minutes on Monday. Let's say it's on mornings, okay. 45 minutes on Tuesday, 35 minutes on Wednesday, 40 minutes on Thursday, 30 minutes on Friday. Right? So let's plot this like days versus this thing, right? So when I was first doing this, I never knew whether this will come out right. Like, okay, yeah. I need to put using plots. You see? Whenever you put plots and all those things, the first time it will take a bit time. I don't know why that happens with Julia. And mine is M1, so it's a bit faster. So, and I don't know about other computers. Like, so that's the thing. I got it so that like in data science, I can just do a lot of work or something like that. So that's the thing. But like, yeah, now I'm just a Ruby on Rails programmer. So yeah, that's a different story. But yeah, it's for this I just bought like, but I don't advise Mac for anybody who truly wants to learn computers. So it's I don't feel Mac is a computer. I just feel it's up. It's you can't tinker with it and all this stuff. So you've got a beautiful plot like Monday to Friday and then travel times. Okay. So isn't it beautiful? Like this Monday to Friday, I just thought it would plot because it should be a number or something like that. But somehow this plots plot. So that's a good thing, right? So, and we have a package called statistics in Julia. And with that, we can find average. Like, okay, what is the travel time that is the mean of travel time in 2020, right? So, it seems to be 42 minutes. Okay, so round about like you spend 42 minutes every day traveling, right? So some days it's less. I think in Friday it's really less or something like that. Okay, so but yeah, like I don't know whether it's right to choose 2020 because you know these days today like it's pandemic and not many people are coming out and all this stuff. Right? So yeah, but yeah, anyway, I've just used some here. That's it. Okay, now let's say like okay, let's for the sake of okay learning or something like that, we say we just take lots of this. Okay, we just take these averages and take some data and give it to our machine learning system, right? So it just says like okay, that the average travel time is this thing something around about 40, and then the upper limit is something around about 50, and a lower limit is something around about 30. Okay, so, yeah, okay, so our algorithm says that more than 50 minutes, if it goes like, ask the person feedback. Like, let's say like we are in a cabs or something like that, right? And this is the travel time that's been recorded for a person or a bunch of people traveling to office or something like that. So we feed it to a machine learning algorithm. Machine learning algorithm says that, okay, if it goes above 50%, ask a feedback. Possibly the driver might have driven very slow or something like that. And if it goes below 30, sorry, 50 minutes, I'm sorry, I told 50%. Okay. So 50 minutes, yeah, ask a feedback. If it comes below 30 minutes, ask a feedback. Maybe the driver could have driven rash or something like that. So this is what our algorithm gives. Okay. So yeah. So fine and good. We ask our feedback and we get very critical feedbacks like, okay, positive and negative feedbacks we just get like when we ask like that, right? So yeah, we are happy with our algorithm, right? So now let's take this thing like 2021 data. Your city in 2021 becomes bigger, more people, more population, more pollution, more plastic, more killing of animals in ocean by throwing out plastic. We have already, I think, killed out all animals, almost all wildlife on land, I think. Okay, now it's time for the ocean to die. Okay, fine. So, uh, okay, so now for 2021, right? We will plot. Okay, so, yeah, so for 2021, we are just plotting and look. Now, the average is round about like 50, somewhat round about like almost near to 60 or something like, okay, slightly greater than 50, I think. So, yeah, so the average is something round about 50. So, if we can look from the graph here, right? So, average is something round about 50 or something like that. The lower limit is slightly above 40, the upper limit is slightly above 60, right? So, if you still go along with the old one, where you just ask the feedback round about like 50 minutes, like when the travel time slightly exceeds 50 minutes. Here, it's just a normal travel time in 2021, right? So the person would have felt normal, and so you wouldn't have got any critical feedback or something like that. And so, if you're running a cab and if you want to do something, you wouldn't know whether the driver is a good driver or a bad driver or something like that. So that's the maybe the driver would have stopped because the customer would need to do some shopping and so like yeah, so he might be a good driver, a customer friendly driver or something like that. But yeah, so all these things are there. So yeah, so depending on the data, you need to retrain your system and something like that. If you let your machine learning or whatever algorithm like or even GoFi algorithm. Okay, I forgot. I haven't told about GoFi. Okay, GoFi means good old-fashioned artificial intelligence. Okay, so just remember your water heater or your what to say. Okay. Remember your good old water heater or your air conditioner or something like that. You set the temperature, and when the temperature is being reached, your water heater stops, your air conditioner stops, or something like that. You might not think as artificial intelligence today, but it was taught as an intelligence system a while back. Okay, so unfortunately, there is what to say. There is some kind of bias in humans. Like humans think that whatever AI problem that has been solved is no longer a AI problem. So back in the old days, it is said like, okay, like this was taught as an intelligent system, or it is intelligent. Look, a temperature is being reached and it automatically cuts off. There is no need for a human to do it. Okay, so it automatically does it. So it is some kind of intelligence, even though it might not have a computing system or something like that in it. But of course, I think modern ACs and heaters have it. But before we had a bimetal strip. So this is called as good old-fashioned artificial intelligence, where you set everything and something like that. Possibly in that AC or heater, they would have had a transducer. That is, transducer means a device that converts one form of energy to another. Over here, somehow the heat gradient is being converted into electrical current or something like that. And that is the heat energy. It's been converted to electrical energy that might give so many volts or so many amps as output. And you just measure that and you just say it like good old fashioned way. Like if it's greater than so many voltage or so many amperes, cut off. Okay, so that's the thing. That is like read the user temperature settings, multiply it by some kind of constant or something like that. And if the voltage is above this thing, just cut off, or voltage is below something, cut off, or something like that. So that's called as good old fashioned artificial intelligence. If you do if or something, if you put if statements or something like that and do, yeah, that's called as good old fashioned artificial intelligence. But there are some articles, but yeah, like I'm just trying to look for some graphical explanation. So no, 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 no. It seems to show something else. I'm not sure what it's okay. So that's the thing. So yeah, so that's good old fashioned artificial intelligence. Even if you code using go for algorithms. Like let's say if the travel time is greater than 50 minutes, ask for feedback, or if the travel times is less than 30 minutes, ask for feedback. That is good old fashion artificial intelligence coding. Okay, so that may not work over here. So in any system, like a data scientist should look at data. If the data differs, or if the algorithm is giving weird output or something like that, ML algorithm is giving weird output or something like that, it should be retrained with the new data, right? And the new and the old system should be compared with the old and okay, so that is, the new system should be compared with the recent data, and only if it's better, far better than the old system, that is like only if it's better than the old system for the current data, it should be deployed or something like that. So yeah, this is what to say, like a term called data drift. I think I've told something in detail. So, but yeah, I think yeah, knowing something in detail is better than not knowing at all. So you can find the Jupyter notebook in my blog. I would put link to it. I don't want to put link to GoFi. That is good old fashioned artificial intelligence. Like it doesn't look what to say, very good or convincing. Even though it is artificial intelligence, people are thinking like it's not artificial intelligence today. That's ironic. Like kind of saying what to say, like not giving the due respect to the engineers or people who created it. But yeah, like that's how this world behaves, right? Once you have solved it, people say it's very easy. So once you have not solved it, people say it is not so easy. So that's how it is. And yeah, you will also find this thing in my video notebooks. You can get my video notebooks over here. Like if you go to about, sorry, and you'll get the link of the playlist, and you'll just get my video notebook link over here. So that's the thing. And what is this? This is about data drift. So let me rename it data drift. Data drift. Okay. So anyway, that's it for the video. Yeah, if you need any topics or something, please do comment. In the next videos, I'll be talking about KNN, like K nearest neighbors and all those stuff. And after that, let's see. Like I want to go into decision trees and entropy and all those stuff. But yeah, anyway, let's see how things go. Yeah. Thanks for watching. Bye.